Cool. That's on. All right. So welcome everyone. This is like about 20 more people that attend compared to last time, which is good. So I'm going to talk about TDS Delta Package and how we integrate that with our CI and CD pipeline. So it's basically a learning that we kind of uncover working with one of the accounts. We've been working with the account for the past, I don't know, 6-7 years. I've been here around for a year, but it's a massive code base. There's a lot of items in it. It has complicated deployment. We try to simplify it. This is one of the learnings that we come up with. So before I go any further, let me introduce myself. My name is Ray. I'm a solution. You don't look the same. Yes, a lot of people say that. This is my actual photo. But yeah, I haven't had a chance to update it. It's just one of those like avatar that kind of stick. So that's my Twitter handle and my website. There's some blog in it. I used to work in Cycor, Southeast Asia, so I see some familiar faces over here. The Cycor guys from Australia, and I saw a few faces that used to work in the QA as well, and some new faces as well. So this is the agenda. So we're going to talk about TDS Delta Package, and then there's TDS Delta Package. I'll explain what's the difference between the two of them. And then once we talk about the Delta Package itself, we'll talk about how we integrate that with the CI pipeline, CT pipeline, and the last thing is components. How all that we summarize that and implement it for a local developer to help speed up their development process. I don't have a lot of material, probably about 20 minutes. So if you have any questions, just ask me. So TDS Delta Package. When Eric from QA first told me to create a material for this topic, he told me that there's not a lot of people who use TDS Delta Package. But let me throw the question around first. Who uses TDS itself or have used TDS? All right, at least half the group. You're gonna try it, just raise your hand. TDS Delta Package itself, how many people actually implement that in a project or even know about it? Yeah? Good. All right. At least someone knows what I'm talking about. So it's to solve this type of problem, right? So especially true, like my TDS file is so huge, it takes a long time to deploy, especially true for legacy project, like the one that we're currently developing on. It's been 5 years, there's a single site instance, there's a lot of site implementation that comes with it, hundreds of content items, hundreds of content as well, a lot of cycle modules. And the way that the design architecture was designed a few years ago, it was like if you build and deploy, it's going to build and set up everything from scratch. It's going to deploy all the cycle files, all the cycle items. It was a design architecture that was designed a few years ago. And after a few years gone by, that's what we end up with, a huge TDS file along deployment. And then another common problem that we have is every time we do a hit branch switch, we do not want to do a full thing. And in a small team, it's kind of easy. You just ask your neighbor, hey, what content item do I need to sync to solve this broken homepage? I can't run anything. Oh yeah, you told me which item to sync. There you go. That level of communication doesn't work so well if you have 20 or 30 developers who separate in multiple teams working on different features. So yeah, it's really awful experience as well if you just right-click one of the side node and sync, because you would end up waiting on 15 minutes or something and hope that would actually solve the problem. So that's quite common.
How about every single day you do a get
Yeah, that's a different story as well. And the last one is the deployment takes a long time. So what is this all about? So basically, what we want is just the ability to deploy a set of change items in a certain point in the past, right? That will relate to your release cycle, your frequency of update content items itself, depends on the pattern that you have in your development team. You kind of uncover the pattern. I'll share around what our pattern looks like internally and how we solve it. So a typical deployment scenario for us previously, right? We have, let's say, about 12,000 content items. And this 12,000 content items, this is our CI/CD pipeline. So we use TeamCity as the observer. OCTOPUS deployed just to deploy the generated nugget package from TeamCity, and that's our integration environment. So that 12,000 content items, that was built by TeamCity as a nugget package. OCTOPUS deploy would then just deploy that to integration environments. So 12,000 content items, depending on the hardware specification that you have. Yeah, it's gonna take some time. Depending how many packages that you deploy as well. Like I said, if you have a single cycle instance with multiple site deployment, you might try to create separate TDS packages as well. So site A, site B, site C. And if one of those site packages grew so big, like 12,000 content per site, I'm not joking, this could end up like 2 hours deployment time. Our previous deployment time was on test environment or integration environment, took about an hour. And even then we selectively select, all right, I'm going to manually install that package and we're going to test it. Yeah, so, and we end up having to manually do TDS package installation as well because of that problem. Because we want to reduce the deployment time of deploying those packages, we selectively, every deployment to integration environment, which can happen multiple times in a single day, we have to go in, selectively select that package I want to install because that contains my code changes. So it's not fully automated, and we want to improve that. So no one had time for that. So enter TDS Delta Package. What is it all about? So it first comes with TDS Classic 5.5, which is in a few years ago, I guess. So it's been around for a while. And its core functionality is about deploying items, chains after a specific date. It's really simple functionality, but it seems that not a lot of people are using it, which I kind of get because not a lot of people would end up in this situation that we have. So if you go to Visual Studio, if you have TDS project, just right click on the TDS project properties, you would see this setting up here. This is the settings that we use at some point to create the Delta package itself. So at the most basic form, you set up a date, and then it's going to generate the package only for the content item that was changed or created since that time, or changed since that time. This is how we do it through TeamCity. So it also accepts a parameter that you pass into the solution file itself. It has include items changed after parameter. Pass it in, accepts that date format. It's going to generate the package, only include the item change since that date. So it's really easy. Any questions?
I'm wondering whether you're going to get to, if you follow the Helix.
I'll get to it. So there's in TDS 5.7, they introduced a concept of update since, because having the ability to set up a date is convenient. But if you have a 2 weeks release cycle, it's more efficient if you just like take 2 weeks of the last changed item, because that's your sprint release cycle deployment, for example. So instead of going, having to go to TeamCity, update the parameter, you just say, I get everything that was changed in the past 2 weeks or 3 weeks. Bundle that package, I'm going to deploy that. So depending on your release cycle, but it works quite well as well. And how you do it? So if you're using that or higher, you have that option. So it added a new option in the last X number of days, which can support through the command line as well. So with those two options, there's a limitation that we feel, right? So with the date after, you can't determine specific commit. So it depends on your requirement, but we need a specific commit as a starting point to generate those delta packages to be precise, right? So with the dynamic date approach, the previous one, where you specify X number of days, you commit to a fixed date range, which is ideal if you have a kind of constant release cycle, right? And a lot of people might stop there, but we went further and we implement Git Delta Package. So Git Delta Package. A few people call it True Delta. So what is it? It uses a specific Git commit ID. It really is more accurate because it's looking for a specific commit ID. So if you have 10 commits within a day, you can specify that as a starting point, that commit as a starting point, and only the commit since that starting point to the end, the date, and generate that package. At the core of it, that's the whole thing. It's using the internal or the available git diff functionality where you specify a git commit ID, the start commit ID, and the end commit ID. There's also an option to specify the end commit ID. If you don't specify, it's just going to take whatever's the latest one. It's filtering using a wildcard. It takes only the changes for the dot item, which is the TDS serialized item. So internally, it's using that to calculate what changes do I need to package up. So by going with this approach, we were able to cut down the deployed change content items from about 12,000 to about 50. Now it depends, right? So with X number of teams that we have, after we fill a site, there's no way we're going to get like 200 more content templates. It's more likely we're going to create, the client would request a banner. That's probably 5 content items. 5 other templates content items. So it fits around 50 content items after we implement this approach, and that in turn reduces the deployment time as well. So the TDS Git Delta Package, this is all the information that you need to generate those Delta package. So you need to install the Nugget package itself. You need to install the Hedgehog development, the TDS itself. You don't need to install the entire TDS software. You just need to install the Nugget package. It will take care for you. That's the main TDS project parameters that you can use. If you use the Git Delta package, you need to specify the custom Git Delta deploy to true. As you probably noticed, that's the Git commit ID that I use. There's also an option to use Git tag name. So for example, if every release, every deployment, you tag your Git with version 150, and then you just increment that version number every time you do a deployment, it will find that Git tag name for you, create the Delta package as well. There's a lot of smart ways you can implement this depending on how you want to approach this. So I'm going to do a little demo. I'm going to show the Visual Studio solution. TDS? Yes. It just takes 2 parameters. You either specify Git commit ID or Git tag name. I'm going to use the one. So this is the Habitat TDS version of the Habitat repository, which is created by the Hedgehog folks. So if I expand over here, that's the Helix architecture.
Right. So the Git TDS Delta, that's
That's the community that built. But yes, Son Homesky, what the solution architect of Hedgehog, did the initial version, and then there's another guy who helped expand that. Oh, I forgot his name. I shouldn't forget because I reached out to him while I was having issues with it. Anyway, uh, let me try to go to. Yeah, so that's the headed TDS. If I expand all of this, it looks familiar. It says instead of unicorn, it's using TDS, all of that. So for this demo, I won't go further into that, but I'm leveraging a feature from TDS itself, which is called package bundling, which basically you can create a separate TDS package project with sole purpose is just for bundling the other projects. So with Helix, some common question about implementing Helix with TDS is, would you end up with a lot of separate package, right? You have to deploy 20 packages. If you use package bundling, no. And package bundling work well with TDS Delta package as well, because if you group all those packets into one, apply the Delta date, commit, or tag name, you would end up with small number of packets and small size of those packets as well. So in this case, I have two bundled. Let me show you the property as well. So for the multi-project property, click. Yeah, so it's basically just a bundle of the relevant master TDS project, and the core bundle is the relevant core bundle project. And inside there, there's a TDS global config file as well that you can set up. So I've created two custom properties, which is for the normal TDS packaging, full TDS package. So that fills out the required information to generate the TDS package. And that's the Git Delta package. The only property that you need to set for the Git Delta is that guy. You need to set it to true. You can also pass it through the command line as well. I just set it there because it's easy to do. And I just call and pass in that specific configuration. It will generate it for me. Any questions so far? Nope.
TDS configuration, bundling configuration.
Yep.
Can you now? I haven't used it in a little while. But can you order your the packages so that this one, content from this one gets deployed before this one and all that stuff, or does it still work based upon alphabetical order?
I see. It's still gonna work based on alphabetical order. You can't.
There's also dependencies. There is like properties. If you go into properties of that one, you can actually have, like, if you have items with dependencies, you can specify that.
There's just two buckets in here. There's like a core bucket, a project bucket, or something like that.
Yeah, it might be on that.
So the first one is like templates in the studios development based on the items in other projects.
Which one? This one? Yeah. So this is
your bundling.
This is bundling.
The first one is your.
That's for code generation. I've never used it before, so I don't know. But yeah, if you want to, well.
I haven't used that.
Yeah.
We tried to use it in a project. And
you have the sort order
solution
issue.
Yeah, it was apparently is wrong. I thought the only solution was to actually number these TDS packages in order to get that to work.
that sounds a little bit like Z dot something we know of, right?
That underscore line.
Yeah, I don't know.
I was just curious. if
Good question,
somebody
though.
knew-
Good question. Somebody else can answer that in the next topic.
Yeah.
All right, let's move on. All right, so that's the demo about the solution setup, the project setup, the bundling setup that I have. The next topic is about implementing all those information that we know of in TeamCity. So generating those Delta packages on build server. So again, that's what we want to achieve. Have 50 instead of 12,000 content items every deployment. You know, on a single day, you do multiple deployments to test environment, integration environment. You want to be able to build quickly and deploy quickly to verify your stuff with spacewalk. That done in a few minutes instead of an hour sitting for deployment to complete. So this is the core concept of it. So we built the solution while passing the actual date. I think for the first quarter, I used the X number of last days because that's one that makes more sense for our sprint release cycle. So for build every change items for the past 14 days. So that's the TDS Delta package, and I then went and explored the TDS Git Delta package. To support TDS Git Delta package on a build agent, I found some pickup. So there's a few things that you need to know. First, if you use TeamCity, you need to run the build agent client using an agent side checkout. The reason is this because it's using Git diff. You actually need to have the Git history in that checkout folder. And by default, it doesn't do that. By default, it does a checkout and put the Git diff on the TeamCity server itself, then put the actual files that's been pulled to the TeamCity agent, not the server. If you have a TeamCity agent cluster like we have, it does that. So you need to use agent side checkout. And then you need to run git fetch. The reason is that it needs to know like every single remote branch that you interact with in a single sprint, because you would have commits everywhere, even though you try to merge that back to, depends on your branching strategy, integration branch, release branch, feature branch, whatever it is. It will, when it tries to run git diff, it will need information on those other remote branches as well to do comparison. Otherwise, you would, I see some missing files because I don't specify that option over there. And the last one is the same thing. You build the solution while passing Git commit ID or Git tag name, whichever approach that fits your development cycle. And I'll just jump through the content with continuous deployment with OCTOPUS section, which is automating those package installation. So if previously if either one of these you've implemented in the build agent and you end up with a small Delta package, the next thing that you want is just deploy that, install that. So this is the gist of it. So we just need to update, we just need to copy those Nugget packets to content management server, install that update packages, and do a cycle publish. There's a few ways you can do this, right? TDS or Hedgehog has something called cycle package deployer. In Finance, we have our own custom, like endpoint or web service that you can trigger, take a look at certain data folder in the file system, find a Nugget package or find a zip file, unpack that, install, and do a publish. But you can avoid all those custom functionality if you just pull that. So this guy, the cycle package deployer, is doing the following things. It's running a cycle background job. So it scans the data folder, the cycle package deployer folder. So in your OCTOPUS, you basically grab the Nugget package, deploy to CM, that folder, and then it has a background job when it runs, and you can specifically trigger the background job as well through the URL. Then it will do the package installation. It does it asynchronously, but if you want it to run synchronously, there's a fork of that repository as well that you can use. Sometimes you want that, right? Sometimes you want to know if the TDS package installation fails, you want to fail the entire deployment process, for example. Now, after that is installed, in TDS itself, there's an option to what do you want to do during post-deploy action. So this is the 3 out-of-the-box option that's available for you. You can trigger a safety event. You can update the link database. What's useful for me is publish after deploy. That means every time I install that another package, it will automatically publish it, so I don't have to go in and manually hit smart publish, for example. Now, while this is really useful, there's a little bit of performance overhead with this approach, because every time even if I have 50 content items, it will try to do a single published item for every single one. That means 50 published action. There's now I know, it's that guy. John Rapper created a fork of this, which is custom action. Instead of doing one for every single content items, it's just gonna take the common root content items of those content change items, and then do a minimized version of published items. So I'm gonna show my local team city now. That is. So this is just an example of different version of generating TDS packets. So at the first version, I have the full package. For the full package, I don't know if you guys can see that, but I have 2 bundled package. Just ignore the core version, even though it's full, but it's really small because it only includes changes from the core database. But take a look at the master one. It's almost 18 megabytes, right? So, and that in itself is quite a lot. If you are planning to do a quick deployment, you're planning to efficiently deploy only the change item, that's not ideal for our case. This is the approach that I first explored, which is using the fixed state. So in here, even though I'm not specifically saying the past 2 weeks, because the Habitat repository itself exists, I don't know, in the past 2 years. So let's say that's 2 weeks, but that's what you end up with. You end up almost 3 megabytes. That's a huge difference. If you're talking about large solution, deploying multiple sites, we're talking about potentially deploying 100 megabytes of content items for every deployment. And then for every release cycle, if we're talking about 2 weeks to 3 weeks, probably gonna deploy about 60 or 100 content items max. So this is the last option that I explored, and really efficient, but it's really tricky as well to get it right, which is the Git Delta. So it's a lot smaller. But the trick is you need to know the specific Git commit ID, or you can use the Git tag name, automate that somehow, based on the release that you're currently on. Cool. Yep. Yeah. Yeah. Yeah.
If there is, say this, chain is, hooked up to release branch, master branch, whatever.
Yeah.
Right? And there's some feature branch that has been lingering around for ages.
Yeah.
A bit stale, put up to date.
Mm.
There's a whole shit ton of commits.
Yep. Yep.
It gets merged into master.
Yep. Well, depending on which approach that you want to take, right? With the fixed state, it's just gonna skip that. Well, it depends on, if it's stale and it's stale for a while, for a few weeks, and you set your fixed date for the past 2 weeks, it's probably not gonna pick it up. With the commit, the strategy that I'm implementing right now is you need to know like what's the pattern that's happening in your team, in your across your development teams. We do have in some occurrences where we do have a feature branch that's stale because we require, I don't know, 4 weeks to develop, test, and fully integrate the feature itself. So on those scenarios, I can go in TeamCity, right? In those special cases, go TeamCity and say, hey, change that. You need to do it. And there's a way to do it, but you're not going to do it often.
Okay, and then when this runs, does it go and set that date to the that commit ID to the latest one? Or
the start commit ID. Yeah.
Does it?
Yeah. If you don't specify the end commit ID, you only need to. What's only required is the start commit ID. You don't need to specify the end commit ID.
What I mean is, do you need to manually go in and change that every release?
For just that particular release.
For that release.
Yes.
So that's still a manual step.
Correct. Yeah. Okay. Unless we find a new way to automate that. Yeah.
Use tagging. If you use tagging, do you still need to do that? Or?
If you use tagging, this is one of the approach that I try to explore as well. If we're deploying version 100, I want to be able to at least just get the last 2 release or something, and that should be enough, right? But if you want to be more efficient, you do this. Tagging, well, yes, tagging would work as well, but if the commit that you tag happens before the stale feature branch commits, then that would make sense. But if not, you would end up with the same problem. Same problem as git commit.
Seems like the only proper automated way to potentially do this is just like you would do with the database in the old days.
Yeah.
Where you basically do a sync, you do a comparison somehow.
Yeah.
Do a comparison.
Yeah.
And build a package based upon.
Yeah. That could be a topic by itself. But yeah, potentially. All right, so.
Do you schedule a full deploy on a weekly just to test disaster recovery?
No, not in our cycle now. But we could because we still have the full version of it.
Yeah, it take ages, like that's just once every week or something.
The way the solution is designed is to build once and then you have everything. That includes the files from Sitecore itself. We have our own fork version of cycle files, DXM files, WFM files, other commerce files as well. The idea of that is when we run full build, we have all those files. We have the website folder populated. It's not an incremental build. It's a full website build that includes every dependencies. Because of that, there's pros and cons, right? The pros is you get everything every time you do a build as well. You include all the dependencies. You can test end to end. Every time you do a deployment, that's every single file that you need. But the cons is deployment took a long time because essentially you're building your website from scratch every single time instead of doing incremental build. Yes, which I'll get to. It's good that you asked. Which brings me to the next topic. So based on all those that we learned, automating package installation, TDS Delta Package, the command line parameters. So the first problem that we saw in the first slide, which is my developers with the branch do a git pull, they end up with a lot of items, their local environment is broken, and they don't know which TDS project to sync. They can't sync the entire TDS package as well. It's going to take them 2 hours, or a feature that they need to work on for 30 minutes. So it's not worth it. So based on all the things that we know, all those steps, which is building the TDS Delta package itself. You can do this locally, right? You can generate TDS Delta package locally as well. Copy that folder to your local CM instance, or if you have a single instance, that's the kind. Hit the cycle package deployer URL, assuming you use that cycle package deployer, and that's it. That's the new development. And if you wrap this in a build script like PowerShell or Cake script, depending on what you use, just run a script. It will take care of it.
Is that automated at the moment? Is that automated?
It's two things: git checkout, run build. Yes. So that's all I have. The conclusion is we're able to reduce our package development time from hours to minutes in all environments, and we're able to solve the developer pain points as well and increase the productivity. That's all.
Have you guys been doing the same thing with Unicorn? Unicorn Deltas?
Good question. So there's a new initiative where we want to migrate to Unicorn now, just because of the
Well, license cost for 30 developers.
yeah that